Okay, so we came up with our linear model here, and a couple of things I just want to point out. Again, we said you can figure this out now for any number. I could plug in 13 or 17 or 6 and just get my answer without having to know everything up through that point. The other thing I want to point out is when we're talking about linear equations and linear models, what makes a linear equation linear and what makes it form a straight line when you graph it is that there's a constant rate of change. And we'll talk more about rate of change in just a minute. But constant rate of change in the simplest way just means that the two variables change at the same amount every time. So every time I order one more latte, my amount goes down by 263. So this went up by 1, this one went down by 263. This one went up by 1, this one went down by 263. It happens every single time. Okay. Now, if they had some promotion where once you've bought 6 lattes, then the next, 5 lattes are 20% off or something, they wouldn't make the same line because the change would be different. But every time this goes up by 1, that goes down by 263. Just like in the pay per gigabyte plan, every time your gigabytes went up by 1, your cost went up by $10. Even with the unlimited plan, it was constant. Every time the gigabytes went up by 1, your cost went up by 0, right? That was constant all the way through. So the last thing it asks you to do here in B, right above that we skipped, is to graph this. So I'm going to let you graph it on your own after the video. Let me just point out some things. Okay, so we're looking at just the first quadrant here because it doesn't make sense to have either negative number of lattes or a negative amount on your card. So we're just looking at the positives. Excuse me. This is going to be your number of lattes along the bottom axis. If you count by ones, you can go up to 24, so you have more than enough space. This is going to be the amount on the card. And if you count by twos, then this line right above the arrow will be 50. Okay, so I'm just kind of helping you out get that set up. And then each of these is a point. So 0, 50, right, goes together. Think about graphing. So 0 and then 50. This is my x value. This is my y value. So I start here. I don't go left and right at all. I just go up to 50 and put a point there. Then my next point is 1, 47, 37. So I go over to 1, and then I go up. Now each of these lines is 2. So there's 48, there's 46. So I'm going to go up. Well, 47 would be right in between these two lines. So I'm going to go up just a little bit. It's not going to be exact. I mean, I can't tell you exactly where 47, 37 is on this graph compared to 47, 44, right? It's just too small on our graph. But in general, you can make a good estimate as to where they are. So you're going to keep doing that. We know that at 20, it would be negative. So what I would do also is go back to this chart and figure out what 19 is, and then you can graph that. You're going to have a graph that basically does this. It's going to go through a little before 20. Okay, we'll stop it here. Makes sense. The amount of money on your card goes down as the number of lattes goes up. Okay. All right, so the last thing we're going to talk about on the next page, well, actually, part D on the next page, will the card last the whole month? If so, how much money is left? If not, how many days will it last? You can answer those either from what we talked about or from the graph. Okay, if you have questions on it, feel free to ask me. But I don't want to really give it away until you kind of look that up. So the last thing we're talking about is constant rate of change, slope, and our intercepts. So we said constant rate of change means that they change the same throughout all of the data. Okay, and another way we can talk about the rate of change is by the slope. So the slope, which you might remember from other classes, we sometimes talk about slope as rise over run, or we talk about it as the change in y over change in X, okay? So in either case, the rise, well, think about a balloon rises, right? It would go up, or an elevator rises, goes up and down. And we run this way, straight across. Or if you think about change in Y value and change in X value, what this means is from one point to another on a line, how does that line change? Does it go up or down, and does it go left or right? And the way that it changes and the amount that it changes in each direction helps us see the rate of change in a visual way. So in this case, for example, let's pretend I'm taking 2 points on this line, and my points are going to be 0, 50, and 3, 42, 11. Okay, so 0, 50, and then 3, 42, 11. Those are my 2 points. They would be on your graph that you just did, or that you're going to do after this video. So if I want to find the rate of change, or the slope, I want to find the change in Y values. So remember, this is X and this is Y. So Y minus Y, I subtract those. And if I do that here, I would get 789. Okay, 50 minus 42, 11. It's going to give me 789. And then for the X's, I'm going to take the same order. So if I did this one minus this one, I have to do this one minus this one. It's going to give me -3. You can put the negative down here with the 3 or out in front. It doesn't matter. I'm going to divide that now. Okay, and if I take 789 and divide by -3, I get -263, or -263 over 1. Now, with a rate of change, it has 2 parts. It has how this part is changing and how this part is changing, and I want to use my units. So 263, what are the units on this? What were the units on these? Dollars, right? So it's going down $2.63 for every 1 latte. That's what that rate of change means in the context of that problem. Okay, that's how it changes. It goes down $2.63 for every 1 latte. We'll talk more about slope and rate of change in lesson 4.2. The other thing that the other places on the graph that are important are the intercepts. So the intercepts are where the line crosses the axes. So there's one here and there's one here, okay, in this particular graph. This is called the y-intercept or the vertical intercept, and this is called the x-intercept or the horizontal intercept. So if we talk about, in this case, the vertical intercept, we want to know more than just that it's 50, right? We want to know, in the context of this problem, what does that mean? Well, that means that for 0 lattes, you still have $50 on your card. That's the starting value on your card. If I think about the horizontal intercept, so intercepts always happen when one or the other value is 0. In this case, my x is about 19, roughly, a little more than 19, and my y is going to be 0. So what does that mean? Well, 19, the x is the number of lattes when my card balance is 0. So that means that after 19 days, that's when my card runs out. So the x and y intercept are not only just a point where it crosses the axis, but when we talk about in the context of the problem, we want to know what it means. So if we think back to the data problem and the plan that was per gigabyte, that graph went the other way. It went like this, right? Here was my my y-intercept at 35. So that intercept was 0.35. This was the number of gigabytes. This was the amount of money. So this is the starting amount of money even when I've used 0 gigabytes. Now in this case, there was no horizontal intercept on our graph, because if I followed this line back, it would have crossed back here, which really doesn't make sense because it would be a negative number of gigabytes. Basically, it's saying there's no way to have a bill of 0, because as soon as you sign up, you have to pay $35 even if you don't use anything. Okay, all right, so that's 4.1. 4.2 is the next one we'll do this week, and then 4.3 next week, and then we'll have a short chapter 4 quiz. There's not a big test because we just do the 3 sections. The nice thing is they're all related. Next chapter or next section, next lesson, again, is graphing, talking about rate of change. And then the third one is talking about, on graphs, finding a line of best fit when your data isn't quite as nice and neat as what we had here. Okay, so please make sure that you've done the P&Ls for 4.1 and 4.2 if you haven't already. Keep working on the OCEs that are due this Friday, and as always, let me know if you have any questions. Thanks.